Greetings, my friends. Today we want to create a function that will send data from the microcontroller to our PC, used for data acquisition or just data visualization. Anyway, we propose to be able to send numbers, float, any type of type. So floating point with two decimal fractional part, integers, negative integers, negative floating points, data 0, 0.23, minus 0. Okay, so any type of number that maybe was read from the sensors or just a command for our system. Anyway, let's start it. I'm using an cortexM4 with a Nucleo board from STM and HAL libraries for the to send the data. Okay, so the setup is already done, so we just begin to write our main function. Okay, so I have a file here called adaptation.c. I also have my main, which is a task which runs at each, it's a cyclic task which runs at 100 milliseconds. Okay, so yeah, okay, so we're gonna choose a name for our function. Uart transmit data. Okay, format parameter float, let's call it data in. Okay, next, so what we want to check how many digits the integer part has. So we just want to make a comment, so check how many digits the integer part has. Okay, so first I will let some space here because we need to declare some variables later, but so we say data in underscore equals to, we take the integer part of the number, data in. Okay, and we declare data in as integer, data in underscore equals to 0. Okay, next, so we have the integer part of the input number. Now we say while data in underscore difference by 0, we want to count the number of digits. So we say data in underscore equals data in underscore divided by 10. So we divide this number by 10 in order to until the data in is equal to 0 in the while stops. So in this time we just increase a counter. Okay, we declare also the counter here as let's say assigned it yeah, and it's to 0 at first. Okay, we save this and move on. So what we have so far, we take the integer part and then we count the digits. Okay, now what we do next? We need to know if the input is integer. If is an integer, is somehow a special case. So is integer a variable, we equals to data in minus the integer part from input. Okay, so we subtract the data from the integer from the input. We extract the integer part in order to see if we will use this variable to check if the input is integer or float. Okay, so we declare this as float. Actually, we only use this to see if the fractional part is different by 0, and we'll consider that an integer. Okay, yeah. So next we will do it, we could check if the input data is negative. Our main goal is to see or to find out the data length in order to send the proper length okay, via Uart. So yes, because we don't want to send more bytes if it's not needed. So this length difference from number to number. Okay, so if data in no, not underscore, is less than, let's say 0.0, okay, then we check again. So from until now we check if the data is less than 0. This means that it's negative. We check also the counter. If counter equals to 0, this we decide we set the buffer length. So we choose a variable buff length equals to counter dot 5. Why 5? We will see in a short minute. We declare here buff length. Buff length is unsigned 8t buff length. Okay, and it equal to 0. Okay, so what do we have here? If the data in is equal to 0 and the counter is 0, this means that the input was 0 point something, or no, it was minus 0 point something, two digits fractional part. So this means that we must choose the buffer length to be sent via Uart equal to 5. Why? Well, 5 digits. Well, okay, as follows: 1 for sine, 1 for the dot, and 2 digits for the fractional part, and 1 for the 0, you know, because if the input is 0 point something, then the while we will not execute this part and the counter will remain 0. Okay, so we need to add we know that in this case we have a 0 minus 0 point something. Okay, else well, if the counter is not equal to 0, this means that we have something different by 0 point something is negative. So example here is minus 0.23, and here at else we just say buffer length equals to counter that 4. What happens here? Well, whatever the input, the integer part is, we will not we will just add to the counter 1, so 4 digits more, as follows: 1 for sine, 2 for no, okay, 1 for sine, 1 for the dot, and 2 digits for the fractional part. So here the example is I don't know, something like this, that 34 with minus. So this 45 2 digits will be counted by this while, and we add for our buffer another 4 more space locations to the okay, 1 for sine, 1 for the dot, and 2 for fractional part that will be sent. Okay, next, so we have this so far we have this code. Next we will check if the data is greater than 0. So this is very no, I missed something. We will check if the input is integer. Okay, so if is integer equals to 0, then the counter will equal to the buffer length will equals to counter dot 1. Why? This means that it's 0. So if the integer part is 0, and we will just add the one character for the sign. So yeah, because is integer is the data, so we will check here if this variable is 0. This means that the fractional part is 0. So the input is integer. So add one digit for sign. Okay. Next, we will else if here to check if the data. So we will keep the same structure, not to be confused. Data in is greater than 0. So yeah. So I will just copy here the same structure as before, okay, and see what changes we must do here. Okay, so we have this one. Okay, maybe I should remove the brackets, but no. Okay, so what we have different? Well, the single difference here is that we will not have the sign, so we just decrease the number of characters that will be sent. So 3, because okay, we will just remove the sign because it's greater. Okay, so the example here, we don't have minus, here we don't have minus, and yes, and here we just remove the entire. Oh, sorry, we will not add one character for sign because it's positive. So yeah, this is the only difference so far. Okay, so okay, we covered some cases. 0.23, this case, this one when the integer part is something, then we covered if the input is an integer, really integer, then we check here if the data is greater than 0, then we check if okay, if the same thing, we just remove the sign, and then we least but not last is that we should check if the input is 0. Okay, if the input is 0, we just create a branch else, and we just define buff length equals to 1 because we just want to send 1. Okay, now after all these checkings, we could just define a vector of chars buff, okay, dimensions buff length. Okay, so we define this one, and then we could we use a function from a library called GCVT, which will convert the data in a string of ASCII. So it's very, very useful, old but useful in this case. So the parameters from this function is data in, which is our formal input here. So data in, the buff length, this could be represents the maximum bytes that will be sent. Okay, allowed maximum allowed size. Well, I choose it the same with our number of characters that I want to be sent, because if I don't choose the same length, sometimes it could initialize with some garbage stuff, and communication will be busy, and I will lose some data. Okay, so this one this I can say like this: define the buffer to be sent via Uart. Okay, this one converts the float number to ASCII characters. Okay, so then we just want to call the HAL library function called HAL Uart transmit, which gets an address Uart. I'm using the Uart 5 here. It's an, you can call it an it's an object, like I will show you, and then we just point to the first address of the vector here. Okay, and this is buff length. No, buff, sorry, this is the buff. Okay, and next parameter, if you look at the documentation, is the buff length. How many? Okay, and then we just let it to FFF here. So yeah, you can check the definition in the library. Okay, I will not stay on this. So our Uart 5 is an handle type def. It was created, it's just a variable of this structure, which comes is needed for initializing the communication and other stuff. Okay, so we're almost done. This is our function. We just need to test it. So we come back to main C, and in this task I'm just already written here. We have a function that will just create a new line here, and then I will just send the data. You see, I'm calling this, and then I will delimitate the numbers by okay, semicolon. So that's all, just a manual testing here. Okay, so let's give it a try to compile and see if it works. Okay, so I've just uploaded to the microcontroller, and then I will just open the serial and choose just open the port. I will change the speed here because I use okay, this speed, and just press open. Yes, so yeah, it works good so far. Maybe it's not the optimized way, but yeah, I will enter now in the debugging mode to see each variable, each value which is sent in this task. So I will just enter in debug mode. Okay, I will try to see if you can okay, so I will put a breakpoint in here in the last just before sending, and resume it. Okay, now I will send the first value from the main task. Okay, so where is it? This is default task. Okay, this one. Now I will send this big value. Okay, it will count the integer part and the fractional part, and it's a positive number, so I should have 1 2 3 4 5 6 7 8 9 characters, ASCII characters that should be sent. Okay, let's try it. Okay, yeah, it is. Let's see if the buff length. Okay, yeah, it was just passed. It passed because now it wants to send the second one. Okay, let's show it to this one. So the next one, which I've typed it here, is minus 60. Okay, like this. It's a double 678.5. Okay, let's say okay. We'll come back here in adaptation and see the buffer. So the buffer, yeah, you will see that this function gcvt returns the buffer which will be sent. It's minus converted to ASCII and other. Okay, and the buff length is 7. Okay, it is 7. This means that we have 7 the length, it's equals to 7. So let's count it. 1 2 3 4 5. 1 2 3 4 5 6. So 1 2 3 4 5 6. Let me check it again here. So minus 6 7 8. So I have something okay. We'll just put here the okay. Now I will send somehow it remains the former length. So yeah, the former length is remains initialized with yeah, okay, no problem. This it's no problem because the buffer length is decides here what to send, how much of this buffer to be sent via, so it's not a problem. Yeah, okay, so next one, 0 minus 0.97 minus 28 and 0 again. So I hope you like it, and thank you very much and have a nice day.